Welcome to 3D Time, from transportation to physics. My name is Ralph Gilman, and this is a multi-part series on 3D time. The first part is entitled Show Me. Let's talk about time, space, and motion. Now, what is motion? Well, motion is change of length or distance, as well as change of time or duration. Now we know motion has three dimensions. So the three dimensions of length are what we call space. Well then, how about the three dimensions of time? They could be called time. Well, how can we show three dimensions of time? We're going to use some maps to do that. Consider a traveler's perspective. For example, a driver looking out the windshield of a car. Now, there are several instruments available to them. Instruments that measure speed and distance. The speedometer provides the travel speed, and an odometer provides the travel distance. Now, for direction and time, there may be a compass, or nowadays most likely a GPS, which provides the travel direction, and a clock or a watch provides the travel time. So then what do we know? We know the travel speed, direction, distance, and time. Now, since speed equals distance per time, we really need just the direction, distance, and time. Let's start with a drive time map. This is basically a road map, and some numbers have been added to it. Now, the miles are in red and the hours are in blue. If you notice, between the cities, for example, on the left, between Indianapolis and Columbus, the distance is 176 miles, and the drive time is 2 hours and 57 minutes. Now, this map is not to scale, so we just have to imagine what it would look like to show the drive times. Here's an isochron map which shows travel times. It's actually quite an old map from Manchester, England, about 1914. And I blew up the scale here. They call it a time zone map. It would be called an isochron map today. And basically it shows the travel time from the city center to the various directions. For example, the yellow area, that's the travel time of 10 minutes. Where can you go within 10 minutes? And the blue area shows where you can go within 10 to 20 minutes. So again, this is showing time, and it's showing it in two dimensions. Let's pause to consider map scales. Now they show the relationship between the map and reality, and they apply to both dimensions of the map. A space scale shows the relation between the map and distance. For example, 1 centimeter is equivalent to 2 kilometers, and it looks something like this. A time scale shows the relationship of a map with duration. For example, 1 centimeter is equivalent to 4 minutes, and it looks something like this. So all we've done is change the units to hours or minutes. Let's look at a couple travel maps of space and time. Here are two maps. On the top is a map of space and a map of time of someone's commute. Now notice on the top we have a scale of 2 kilometers, and on the bottom we have a scale of 4 minutes. Now look at the top, and you see the rural section of the trip is fairly long, and the corresponding section on the bottom is shorter. Now this means that the amount of time it took to travel that longer section was less, and so the speed was greater. This is a way of showing the difference between the space and the time perspective. Even though they're similar, the top and the bottom are similar, they're still not the same. Let's show a map of European rail travel times. Now this looks roughly like a map of Europe, but instead of distance, it's showing time, and of course time in 2 dimensions as we've been doing. And yet it looks distorted. It's not the same as a space map. Well, that's because it's not. It's a map of time, 2 dimensions of time. In conclusion, we've shown some 2-dimensional maps, and these show space if the scale is in distance, and they show time if the scale is in duration. Now we know that motion is 3-dimensional, and that means it has 3 dimensions of distance. Well, it also has 3 dimensions of time. But 3-dimensional time is impossible, you may say. Well, then watch part 2, Objections.